Okay, let's work together. How do I get from x4 to the limit? Get 4x cubed. 4f that. Go. Good time to practice coordinating, right? So tomorrow we're gonna have the quiz up to 2.3. 2.3, up to 2.3. Therefore, tomorrow it be expected to do two things, formula and limit like this. Okay, for some kind of function. And yes, it's same idea. Okay, you're gonna have formula, you're gonna have limit, perform limit. Okay, if you expand the x to power 4, yep, it's gonna be a little bit of do the legwork, right? But should be this. There. Experience will give you that. Or 4 times. Should give you that. 4 and come back. Okay. Like I said, whatever you do, your answer should be that. That should be your answer. Okay. That should be your answer. This and this go away. And only the one with the h term, single h, cancel. These two terms, right? Single h. These two h go away. This term x square, you still have an h. After the cancel, you still have an h. You go to 0, that goes away. That's a 0. That's also 0. That's also 0, right? Right? These two cancel. Right? 0 here, 0 here, 0 here. These h go away. You have 4x cubed. There you go. Okay. All right. So let's do that. Go. 1, 2, 3. 4, 5. Okay. So a bunch of them go away. 4x cubed plus x squared h plus 4x h plus x cubed. Okay, go to 0. Basically 0, 0, 0, There you go. That is derivative. Check that. Consistent with the power rule. Yes, that is actually what happened right here. Again, one more time. It's not that simple, right? Here to here is this thing. Okay, you just right now you using the result. Right? You're using the result. You bypass the limit. You get to the answer by formula. Okay. So, okay. Any question? Okay. Differentiate. Okay. From now on, you can use the derivative formula unless stated otherwise. Okay. So unless I say use the limit definition, then derivative. Okay. So work together. Try it out. Work together. Discuss. Use formula. Every time you have an answer, compare with your friends. Do you have this? Do you have that? So each one of them should take you one single line to do, right? Equal. Right? And maybe this one too. But very straightforward. Because now you know formula. You don't want to do, okay. That. Okay. Discuss, compare, team. Correct, there. That is. Correct.
If this one, when we bring down for C, obviously, or can I bring the S to the 5 up by
Yeah.
S to the
That's the only
5?
way. That's how you do that problem.
Okay.
That's the only one. That is the technically the only option. That's what that's problem.
What did I do for C?
1/2.
Okay.
Okay. Correct. However, can you try another writing, another expression of this one, which is only going to be your formula too. Another expression. So write this differently.
Okay.
That's correct, but I want you to write
Yeah.
differently. Try that. Might have put the chat. Hold on. So the formula is going to be correct. That's correct. But according to the power rule, what do you? Okay, right here. You see that negative? How you go to the front, right? It's 1/2. You're missing just 1/2. And then that 1/2 you subtract one negative one, correct? Yeah, so you're missing 1/2. Correct? That's how you write that. And use the power rule. Go to, if you don't remember, go back to the formula. Previous page. What do you do with this one? The power will go down, subtract 1 to the power. Let's see. For this one, you want to write out x to power -5. That equal x to power -5. If it's in the x in the denominator, x to -5. That's correct. However, there's a formula for this particular part.
Okay.
Can you read? This is correct, but can you rewrite this one differently?
Okay.
Like right then, I think x is 2x to the x minus 1 and then pi is a constant, so
That's gone. That's gone. It's only if it's like.
Did you just press 1/2 minus 1?
Really answered, we gotta include it.
Did I see correctly?
and
Did you say 1/2? 0.5 minus 1. Did you pull out a calculator? Right. Correct. But however, I want you to try write this one. That's correct, but try write that differently. That will be also the formula for this.
For this one, do you rewrite it like the same as how you do the
To
other ones? Like
1/2?
X to the 1/2?
Yes. And then you apply the formula just for the x to the 1/2.
Okay.
Number 2, just leave it
This
there.
one is just a constant, so it's just
Yeah,
zero.
yeah. That basically, no, not zero, not zero. Constant. That would be the way the previous page. Go to the previous page. Right here.
Oh,
So C x something is going to be C in the front. Just technically C in the front. Okay, good question. What do you think about? Discuss? Sure. Yeah, there's a formula for that.
I'm having a lot of trouble remembering what I should already know. Right so far.
Okay. So 1/2 G prime. Okay, okay. So technically, each one of them start with this one right here. You drop that down, you minus 1 because it's correct. However, you do something with that number 10. Where's the previous place? That power is going to go to the front. And
Oh,
you're
shit.
missing that number.
Oh, okay.
So that 10 going to be. So each one of them.
Gotcha.
10, x9,
Yeah.
20, 26, T.
Okay, thank you.
There you go. No. Okay. So each one of them is just a bunch of power rule, right? You just have, it's come down to identify the power, the correct power, right? That is the one we're looking for, right? So y prime. And in this case is 10, right? Clearly. 10 minus 1? 9. Okay, root 5. Root 5.
2026 T 2025.
Correct. Root 9. Okay, before I do the derivative, I want to rewrite that one. Rewrite that one. Okay, root 9. What would be the exponent in this case? Just rewrite that. Not derivative. Just this. I want to s to power something. Where's that? That would be negative 5. Right, exponent. So that negative 5 would be your n in this case. Okay. So root 9. Let's finish this one. So if derivative will be negative 5 minus 1. There you go. Careful with the negative. Right, negative 5 minus 1, negative 6. Okay. Root 12. Square root.
Negative 1/2.
Square root. 1/2 only. 1/2 only. Yes, we're going to have negative 1/2 somewhere in there. But no. Okay, so now we take the derivative. Okay, so can you finish that? Still root.
That's 1/2 W to the power of negative 3x. Yeah, right.
Negative.
Negative 1/2, right?
Negative 1/2. Oh, actually, okay. We can slow down for you guys over here. Right? Formula, right? 1/2 minus 1. And somebody use the calculator. Punch this one for me, right? Negative 1/2, right? Yeah. I saw that. I saw that. Break my heart. Right. Okay. 1/2. But however, I go around. I saw a lot of correct answer this. But I asked you guys to rewrite this one. That's correct. But I want to rewrite that differently. Okay. That's done. Okay, and that's also a formula because you see square root a lot. Square root. So derivative of square root, in other words, derivative of square root of x is 1 over 2 square root of x. More or less like a formula. It's common. If it's common, then consider it's a formula. Okay, square root is very common. X square, common. X also very common. Tangent, sine, cosine, yeah, very standard formula. So that square root derivative give you this. Okay. So you don't have, when it's common, so you can, from here, you write out the answer right away. You don't have to do subtract 1, use a calculator, get this, and then get that, right? Okay. But this one. Any root? Want to chip it? Go ahead.
18x to the power of 5.
18, okay. Correct. All right. So, but before I put the 18 down, I want you to write down, okay, so 3 is still there. We multiply by 6x to the power 6 minus 1. There you go. So when you apply the power rule, you apply it to x6, right? X to the power 6. So 6 go down, x to the power 6 minus 1. That number 3 outside, keep it outside, right? Okay, therefore 3 times 6, you have 18 x5. Okay, so now term by term, huh? Okay, who's get lucky to be the first term? Okay, number 1. First term only, x8. Number 1, x to the power 8. 8x to the power 7. 11. Next term. 60, yes, 12 times 5, 60 to the 4. Okay, correct. Root 4. 4.
X to the negative 1/2.
Okay, you see that square root? Apply this one.
Oh.
So you have 2, right? 2 is 2 right there. Square root of x will be 1/2. Yeah, keep going. Square root of x, that there. Okay. Square root by itself give you this. The square root give you this. And then that number 2 in the front is this number 2 right there. Okay. Good. The next one also common, 1 over x. Root 10. Okay. In other words, what will be the derivative of this? Root 10. Where's root 10? Where's root 10? Oh, root 10, okay. What will be the derivative of 1 over x? Just do normally, traditionally. You're going to have x to power negative 1 derivative. Use the formula, you have negative x to power negative 2. Okay, that negative 1, it's just negative, right? X to power negative 2, x squared, the negative one. So this is also a common one. Derivative of 1 over x, is negative 1 over x squared. Okay. Therefore, right here, this term. Okay, I'm going to use a color purple. This term is minus 1 over x squared. Okay. The last two one is tricky. Okay, I put in there intentionally, put in there so you can see the difference. What do you think about 2 to the power x? That's one option.
2x x minus 1 and then power.
That is another option. Okay. Just let you know, okay? No, nothing personal, huh? But all of them are wrong. Because you haven't learned it yet. You haven't learned. Because the power rule apply for power function only. Apply for polynomial function only. Power rule, x to power n. X, the variable, is the base. N is the number. Only when you see a number in there, you can do this. This is exponential function. Pay attention. Compare the difference between them. The base, that is x, this is 2. The variable is a number, the variable is x. They are different kind of function. The power rule does not apply to this. There's another formula for that you haven't learned. So we're gonna learn it maybe in at least two weeks from today. So it's still a long way to go. Okay, maybe 1 week from today. Just give it to you. Okay, but you haven't learned it yet. But I still put in there to tell you the difference. Derivative of x squared, which is a parabola, is 2x to the power 1. Okay? I use the power rule for this. Derivative of x squared is 2x to the power 1. Okay? Normal. Okay. This is exponential. 2 to the power x. Exponential. Polynomial. Different function, different derivative formula. Okay? Keep that in mind. Okay. So I just put it there. You haven't learned it yet. Okay? Haven't learned plus haven't learned. There, let me put it there with you. Good? But pi to power 4, you learned that. Which number I haven't got? 0? Beautiful. 0. Why? That is a constant. Pi is a number. 3.14, right? Raised to power 4, whatever that is. This basically a constant. Derivative of a constant is 0. Okay, that is pi, not x. X to power 4, then you have the other one. This is pi. Okay, so be mindful when you read the function. Okay, so far good. Okay, power rule, relatively simple and easy to apply, huh? Next rule. Trick. Yeah, trick. And make sure. Did I show last class? Second. Okay. Just throw it out there for you. Okay. Cosine. Derivative of sine is just cosine of x. Okay, they just fluctuate back and forth. Derivative of cosine, negative sine x, correct. Derivative of tangent, secant square. And secant, okay, secant is 1 over cosine. That is another way of writing. So 1 over cosine square. Secant is 1 over cosine. Okay, and derivative of secant, that means derivative of 1 over cosine. Secant times tangent. Or tangent over cosine. Okay. Derivative of cosecant is negative cosecant times cotangent. Basically, negative of cotangent over sine. Because cosecant of x is 1 over sine. Okay. And lastly, derivative of cotangent, a negative cosecant square. That's negative 1 over sine square of x. Sine square. Okay. In here, even though they are a bunch of formula, right? A bunch of them. For the sake of calculus, you should memorize these four only. 1, 2, 3, 4. Okay, those are the four that you keep seeing. Okay, because technically, my personal preference, I hate cotangent. Yes, because I know cotangent is 1 over tangent, right? Just a reciprocal of this. Cotangent is reciprocal of this. So knowing this, basically you know that. Okay. Secant is enough to tell the relation between cosine. Okay. So secant is enough. So in other words, I don't like these two. Okay. And most of the professors, they don't like these two. Okay. So these one. Make sure, even though you have formula, you'll be able to use formula. But make sure you get those formula memorized by final. Okay, memorize final. And if you go to Cal 2, that will be an assumption. Your professor will assume you know those. Okay. All right. Okay. But for now, before the exam, at least get these three. These three are very simple. Sine is cosine, cosine negative sine. Tangent is 1 over cosine squared. Okay, so let's do. Find the first derivative. Find derivative clearly of sine. What is this? What is this? Sixth power? Raised to the sixth power? Is that raised to sixth power? 6 prime. 6th order. 6 prime. What does it mean? Okay, in plain English, if you explain that to a high school math student. Yes, derivative of this 6 times. That's it. Is it too much? Try that. Is it too much? I'm not crazy to ask you to do something, so wrong, right? Is it too much? Try that. Check the derivative 6 times. Derivative, and then derivative, and then derivative. And keep going. Okay. You're going to see the pattern. First, second. Okay, and in terms of notation, after the third one, you don't want to put like a 4 prime like that. It's going to look confusing. After the third one, only 3. The first 3 you have this notation. After starting from the 4th, you can use the number, but put that in parentheses. 4th, 5th, and 6th. Okay, the first 3 you can use the quotation mark, right? Okay, so try that 6 times. Yeah, the formula. Right. Be sensitive with the sign, huh? Okay.
Does the negative sign stay with it, or does it?
So you feel that the negative still there. So you take the derivative of the whole thing, negative sign. So sine will give you cosine, and then that negative, yeah. Then next time you're gonna do, you can still have that cosine negative. You still have that negative plus the negative in the formula. Yeah. Okay.
That's what I was wondering because I was like, well, kind of.
The sine. I actually started finding derivative of sine, so then I got the derivative of sine is cosine x. And
The sixth one is negative sine x. Negative sine x, right? Negative sine x.
and then I can use
Yeah. Just flip back and forth, but you have to be a little bit careful with the negative sign. So the first one is sine, cosine. But the second one, derivative of cosine, is negative sine. The third one, you take the derivative of this thing, but there's a negative in there. So the derivative of sine is cosine with this minus. Drop down. Therefore, when you take the fourth one, you take the derivative of this with a minus. So cosine is negative sine. There's a negative in there. And this negative. So negative, negative, positive. Right? And now you go one more round. Back to the cosine. To negative sine. See? So, try if you can get the pattern. If I do that, you're going to do on the way to 20. Try it for fun. Okay, you only have a certain limit of percent. You see, okay, what is the whole lap? The lap. Start with sine. Whenever you see the sine again, you finish one lap, right? One rotation, right? You at the fourth one, you see this. You have the first one, you always have the cosine. Second one, you have the negative sine. There's somewhere the negative cosine. Third one, the fourth one, you're sine, and then you rotate again. Fifth is cos. Six is negative. Technically, you go here again. 7 gonna be this. 8 gonna be this. So what would be 2026? Discuss. Think of it. Get the pattern. Okay, discuss. No?
Well, that's only because you have to do the pattern. It's so those negatives, cosine, cosine, negative sine. Sine, cosine, negative sine. So you had to write that forward. You have to do negative sine.
Okay. Any group? Any group
Negative sine.
can have a clear. Okay, actually, get a piece of paper out. If any group can have a clear explanation of this, correct, and clear explanation, you get 3 point extra credit for the quiz tomorrow. 3. You just make up my words. Actual piece of paper. Right, approved. Show why is that? If it's correctly.
Would you want something a little more articulated than that?
More. I mean the paper wise. Get the paper.
Oh, he wants a full paper.
Full paper. Get a full paper. Don't just make a full paper. Okay, at least yeah. That paper is fine.
If it's divisible by 4, then it's.
Why? Back up your explanation, huh?
So if it starts also down to put down whatever the group wants to put down. Like after the fourth one, it's gonna be like. I think trying to be signed.
If that makes sense. I'm not going to break up this
Okay, so the fourth derivative would technically be as if it was f of x.
Yeah.
F of x. So then you gotta find the first derivative and then the second derivative. Because the fourth derivative is 2x. Then you add the first derivative. And the other one.
But I'm more
Okay, let's go for one more minute. Write your explanation. Can you get the full paper? Yeah, okay. In case I lose it. Yep.
And then like derivative of 6 was sine, and then derivative of 2 was so if the derivative is positive, it's gonna equal sine.
So, okay. Group 2. Can you help me put your names too? So it's easier for me to input the.
Because the derivative is positive.
Okay, time's up. I'm gonna collect the paper. If you want to turn in. Okay.
What if I verbally explain it to you?
Huh?
Alright, let me write the group.
The room, at least the room number and the names. Okay. Room number and the name, so I can trace it.
Yeah, group 5.
All right. Thank you. All right. Oh, my bad. Okay. Okay. All right. Start this one. Okay.
What if I show you the explanation I have on my tablet? It's 2024.
It's about, okay, explain it now is one thing. It's only half of the calculus. Calculus is about writing your explanation.
I did? Okay, I wrote like
So I wrote like the nearest
Good?
like number that's like 9.
Okay.
Give me a second.
Okay, second already passed. Yeah, she just said that, right? 1 second. Uh-huh. Okay. Okay, how about you guys? Okay.
That means that you can divide by 4 to then get the same value. So you divide 2026 by 3.
3, 2, 1. All right.
24 divided by 4, 506.
Okay.
Then you take
Okay. Everybody got it right? Okay. Everybody got it. Okay. Say your answer. What is it? What is it? Negative sin x. But how do you explain it? That is the key. How do you actually explain that? How do you convince? Okay. The answer is this. When I ask you to explain, that means okay. My nephew is doing calculus. When I explain it to him, not calculus. Okay, actually you have your cousin. He's taking high school. Explain that to him. Why the 2026 derivative of sine x is negative sine x.
Well, I could say that there's like a pattern that repeats every fourth derivative. So then instead of dividing 2026 by 4, I divide the closest factor, which is 2024. So 2024 divided by 4, I got 506.
Okay, technically, so in other words, you can still do that. 506 with remainder of 2, right? Okay, right? You do 2, so you repeat that for every 4 derivative. You return to the same thing. So after 506 cycle like that. So at the 224 derivative, you return to this, right? Now you go 2 more. 5th, 6th, there you go. That's the explanation. Okay. See the pattern? In other words, okay, why do I give you this example? You have a function that is differentiable. You have a function that you cannot take the derivative. Swear, remember that? You cannot take the derivative at 0. You have a function that you have limited differentiability. Limited differentiability. Limited differentiability limited, what does it mean? Okay, help me. Derivative
3x minus 1.
3x
Squared. 6x.
finally
0.
limited. You stop there. You cannot go further, right? Here, 4th derivative is the maximum you can go. And now you have unlimited differentiability in a trig function. You can take limited forever. 2026, you can take 2 million or 100 million, it doesn't matter. Okay, so unlimited differentiability, limited, undifferentiable, differentiable. See the connection? See those examples? All right. Now try this. Okay, I think you get the idea. Okay. They are basic. They are very simple. Try A, B. Try if you can. Try it if you can. But it's basically chain rule in here. I snuff in chain rule. I illegally do this, but I just want to push you guys. Okay. Basically, you don't have the tool or the formula for this yet. But guess, make an educated guess. But those two, yeah, you can do that. Those two, you can do that. Okay, just phi cosine gonna give you this one. A prime. Okay, and also remember, don't just another way of incorrect writing is this. Phi cosine x minus 3 secant square of x. That is incorrect. Why is that? The first line is not equal to the second line. The first line is the function. The second line is the derivative of that function. They are not equal. Okay. So yeah, that formula up there. How about this? Okay. Discuss. You haven't learned that. You haven't seen the formula for that yet. But try to guess.
You do to this one and to this one.
Okay. So later in 2.5, we are 2.3 right now. In 2.5, you're gonna learn the most important rule in derivative. It's called chain rule. The most important one. Would tell you this. Psi, okay, actually let me use another color, so consider this a formula. Psi of u. When you have derivative of a function, not just variable, u is a function. Okay? When you have derivative of a function, psi of a function, you have that function u prime multiplied by the normal formula for this. Regular formula for psi is cosine. Okay. And this applies for own trick, cosine, tangent, cotangent. So you have cosine of u. Remember, u is a function, not just x. X is alone. Okay. So you have u prime times negative psi of u. Tangent of u is u prime again. So technically, if you have derivative of a function, you bring that function to the front. You take the derivative of that function and you multiply to the derivative of this. Tangent is secant square, but not x secant square of u. There. All of these are chain rule, which is going to be, we're going to discuss in depth in 2.5. Okay. Now we're going to just use the result. Okay. So one by one. First term, just phi. Start with phi, right? Start with phi. Because phi there. Nothing, the constant stay there. But I have psi of u. If you have psi of x, if you have psi of x, it's just so simple, right? Cosine of x. You change that x to something else other than x. The moment if x alone, okay, you can use that formula. The moment you change that x to anything like this, that is u already. That is a function already. That's basically a quadratic there. Different already. Also different. Each one of these are function, not just variable anymore. Okay, so all of them, in short, they're just u. Okay, that is also a function. Okay, so function, so what do? We throw that function to the front. That function, in this case, is that 2x. 2x. Derivative, yeah. Just mimicking this formula right here. Okay, u is this case, where u. So throw that to the front, take the derivative of that, so put that there. I haven't taken derivative yet. I'm about to. So derivative. What next? Multiply cosine of u. Cosine of u, cosine of 2x. Okay. Derivative of 2x is 2. Right? Derivative of 2x is 2. 5 times 2? 10. Times cosine of 2x. Okay. I just did that for the first term. Can you try that for the second term with the near? Okay, try that. Try it again for the tangent. The formula right here. Try again. U in this case is going to be 4x. X squared 4x. Anything other than x is a function. Then you have to do the u prime in the front. Compare your answer with your friends, with your neighbor, in your group. Look around. Okay, so 3. Drop number 3 down. Time the u is 4x, derivative of that. Multiply secant square of u, not x. Secant square 4x. Okay. Derivative of 4x, 4 times 3, 12. Okay, good. Okay, we're gonna do a lot of example like this in 2.5. It's called chain rule. Chain rule. Okay. Now, power rule down. Now ready. Now next, product rule. Recall derivative of a sum or a subtraction or minus. Okay, subtraction or minus. Okay, subtraction. So a derivative of a sum or derivative of a difference, subtraction or difference. Basically, you can split them. F prime plus G prime. Okay, F prime plus G prime. Derivative each one of them. Or minus. Okay. Right? Right or wrong? You actually just did that to answer that question. You just did that right here. You just take the derivative each one of them. Right? You do it one by one. Clearly, you just did derivative of a difference. Derivative of this minus derivative, right? You also just did that right here. You did that how many times? 1, 2, 3, 4, 5 times right there, right? There are a bunch up in there. So derivative for each term, derivative of a sum or a difference, it's just derivative of each term inside. Simple as that. But it begs the question. Is the derivative of a product, is it equal derivative of each one of them? Then you multiply them. The answer is no. Okay. If you have a product, a multiplication derivative of a product. Right now I'm trying to write in 2 different notation. You see how I write that? Right? Different notation. Prime notation. Leibniz notation. You have a product rule. The product will say like this. It will be F prime G plus f g prime. Okay, if you see a product, that's how you take derivative. F prime g plus f g prime. Okay. Not so complicated, right? Okay, let's apply that to this one. First, in order to know, okay, you have to verify whether you have a product or addition or subtraction or quotient, right? Clearly, right here you see a product. Where's the product? Where do I put the dot? In the middle between these two, right? So in this case, the x squared, that is f, the cosine, that is g. Okay, purple one and the black one. Okay. So if I take the derivative according to the formula, okay, I have f prime that is x squared. Okay, I'm not going to take the derivative yet. I'm just going to write down according to the formula. No derivative yet. F prime times g, the black one, cosine x, plus f times g prime. You see that? Just mimic exactly the formula up there because I have a product. Apply the product rule. F prime g plus f g prime. When I write out like this, now I'm able to take derivative. Okay, term by term. Right here, in this term, I only take the derivative of this, which is 2x cosine x plus x squared times. There you go. Okay. Everybody write your A ready. There. Very good, very good. Cosine x plus x squared times negative sine x. Okay, there you go. That's simple. Okay. With that being said, let's try next one. Identify, okay, do the same thing. In here, A and B are constant. So I give you something arbitrary. Instead of 2, instead of some number, just 8. Okay. You're going to see this kind of problem multiple times. Okay. Where you have to identify, okay, what is the variable? What is the constant? A and B in here are constant. Treat it like constant. Think of this like 2 minus 3t, 5, 10. Think of this like a number, right? In here, there's a function of t. H of t. So you're going to derivative in terms of t. Okay, try that. Discuss with your group. How do you do that? And not only one, I want you to do that in 2 directions, 2 approaches. This problem you can do in 2 different ways. Okay. There you go. And they have the same answer. You can do it 2 ways. Use different rules. Okay. Did I call group 3 already? Yes, right? No? No. Okay. 3. Group number 3. Where's group number 3? Where's group number 3? Number 3? Okay, group number 3. You get to choose the first approach. Which rule you're going to use? We are in product, of course, it's product rule, right? Okay. So product rule. If you do product rule, first approach, product rule. What do you have? Huh? So what did you write on the first one? The first line that you get.
Well, what we first did was distribute T.
Oh, you distribute. Okay. That's actually the second approach I'm looking for. Distribute. Okay. So let's do that. So next group I'm gonna do. Okay. So the next group I'm gonna ask you for the product rule, huh? But for now, group 3. You distribute. So what do you have? Go ahead. So distribute. That means I didn't take the derivative yet. So distribute. Go ahead. Read it for me.
Can we come back to you on that?
Huh?
Can we come back to you?
Come back to you? Okay. I'll be holding on that. Okay, so 2 more minutes. 1 more minute. Okay, so group 3. Group 3 is going to give me the answer for the distribution. The next group I'm about to call, I'm going to give me the answer for the product. Okay. I'm just going to give it out. The group that will give me the answer for the product rule will be group number 7. Where is 7? Where is group number 7? Where's number 7? Okay, number 7. Okay, I'll give you 2 more minutes too. Okay, just let you know in advance. You're gonna give me the answer for the product group using product group. Okay, now back to number 3. 2 minutes up. What do you have? Distribute first. Take your time, distribute first.
Yeah, I got
Mm-hmm, uh-huh.
So what I got was 18. Like, so 1.5.
I'm sorry? 1.5, right? Okay. Minus B, okay. BT. T to 1.5. Right? Okay. Right now, keep in mind, we are just only distributing. We haven't taken derivative yet. Okay, so just distributing. How do you combine these two? In group 1.5. T times T 1/2. Okay. Back to root 3. Somebody else. Okay, you already did your wonderfully. Next one in your group. T squared times T squared. Gentlemen. T to the 4. How? Why? What did you do? What did you do? That is correct, but what did you do? T to the...
Sorry, is it not addition? I mean, exponents.
Earlier, you just add 2 plus 2, right? Keep doing with that. Keep doing.
Okay.
So that would be correct. Same idea. One half is, okay, think of decimal number. One half is 0.5 plus 1. 1 and a half. 1 and a half is, okay. All right, so distribute. The last one in your group. Last one in your group. Last gentleman. Derivative. Derivative. Remember, okay, I give you a hint. A is just A, leave it there. Just take the derivative of T 1/2. Huh? Okay, T to power n, derivative is going to be n T to power n minus 1, right? Okay, n in this case is 1/2. So if you take the derivative of this one, what the first thing you're going to write? Go ahead, the whole root. T to 1/2. 1/2. T to the power negative 1/2. There. B. Keep going, same pattern. 3/2. T to the 3/2 minus 1. Two over 2 is 1. Okay, that is the derivative. I'm going to clean that for you. Okay, so that would be the answer if you distribute. Now, yes?
T to the 1.
To T to the 1. Which one? Which one?
For mine.
For the...
Minus B times 3/2 times T to the 1 as you subtract 1 from 3/2.
Subtract 1. Oh, yes. 1/2, 1/2. My bad, my bad. Thank you, thank you. Thank you. You are right. There. So it's going to be square root. Okay. Now, root 7, right? 7, right? If you do product rule, see, let's see if you have same answer. Okay, product rule. Go ahead. You can say like derivative first. You can say according to the formula first, you know. You don't have to say the answer right away.
We got
Product rule, product.
how do I word it? 1/2 T to the power of negative 1/2.
Okay.
A.
So that basically, where did you get that from?
Oh, the
The derivative of this, right?
yeah.
Yes. Multiply by?
A minus BT.
Okay, what next?
Mine plus
Plus the A minus BT.
BT, the derivative of
Okay. And square root of T. Right. Okay. So you only take the derivative at 2 places. Square root of T, which is 1/2. Go ahead.
T squared.
Square root.
Having,
Square root of t.
yeah, square root of t. There we go. My bad.
Okay, square root of t. Okay. A minus bt plus, what will be the derivative of that one?
Oh no, minus b.
Minus b. Everybody agree? Because a is constant. Derivative of a is 0. Negative bt is just negative b. Okay, times square root of t. Okay. How do we get from there to this? I want every group to try that. Simplify this. Because it has to be the same. Because they are technically the same problems. Simplify this so that you get to this. Or do whatever to this, you get to be this. Try that. And we can call it a day. Try that. So now just algebra, huh? Just algebra. Get from here to there. You should get the same answer. First, distribute this inside, right, term by term. Right. When you distribute this to this first term, to the a, you already match this one. Right. You distribute to the a, you match this one. You distribute to the negative bt, you're going to simplify that, or you combine with this term. You combine this with this. You're going to have that negative 3b over 2. Okay. A lot of confusing eyes, huh? Correct? Correct? Okay, just distribute. Drop down. Okay. This term match this term. So I'm not going to worry about that. Look at the b, the term with the b. Ooh, what's that? I see t in the top. I see square root of t in the bottom. Can I do that? Okay. You guys scare me. Okay. Is it?
Yeah.
Right? That's how I got to that. The negative b, the over 2, copy and paste. Okay. How do I combine these two? Negative b over 2. Okay, b negative, technically that's negative 1 over 2, the same term, right? Same term. So negative 1/2 minus 1. Right? Am I right? Negative 1 over 2 minus 1. Negative 3 over 2. And the first term, which consistent with the other approach. All right, we're gonna do more fun tomorrow. Okay. have lunch. Okay, go grab your partner, go have lunch. A team as a team. Discuss, work together, study together. Strategize your learning. If your group, there's one in your group, I think group 10, right? Okay. Give Alex an email, right? Hook him up. Okay, see you tomorrow.
Message you guys on camera.